Now that we have applied the West System epoxy to the entire interior of the rocket and to the fins, and we let it sit overnight to cure and really soak into the cardboard and strengthen it from the inside of the rocket, we are going to get started on applying the body wrap and painting and priming. For the body wrap, it is really straightforward. It's just a matter of applying it directly to the cardboard tube. The airframe of the rocket doesn't really require any kind of priming or painting underneath. You can, if you'd like to, spend some time priming and sanding it down and smoothing it out just to get a really uniform, even application of the body wrap. But it's not necessary. You might see if you don't do anything at all, and I'm not going to do anything underneath the body wrap, but you may see some spiral tubing or some other minor imperfections, but not really a big deal. It's really as much time as you want to spend on it and polishing it, making it look really nice and cleaned up. But again, the vinyl body wrap does not need anything underneath it. We're going to apply that first before doing any painting or priming. And once the body wrap is on, we're going to completely mask that off, protect it, and then take the nose cone and the fin can and prime them and paint them. Again, you can spend as much time as you want to or as little time as you want to priming and painting. You can go through a couple rounds of priming it, sanding it down, any imperfections, get them out, and prime it again, sand it again. We're probably just going to do a single coat of each, sand it down, and we'll be ready to go. Show that in the next couple steps. You also may see in the corner here we have the finished prototype of the L3 Fusion rocket, just to give you an idea of what it's going to look like once it's all complete. Body wrap having been applied, painted, primed, and good to go.
After applying the West System epoxy to the inside of the airframe, the tube is just being sanded to remove any excess buildup. And now it's time to apply the vinyl body wrap. Again, no need to prime or paint underneath. You can apply the wrap directly to the cardboard tube. Start by doing a dry test fit. Line up the wrap with the edge of the table or workbench, and with the edge of the rocket airframe as well. Roll it on the same way you'll do once you're actually applying the adhesive. This helps ensure that it's going on straight. Once you line it up, carefully unwrap it again, and gently roll the rocket off the wrap. Don't pick it up and move it, just roll. That way you know you can roll it back on exactly the same way. Now that you know how it'll fit, it's time to peel off the entire adhesive backing, leaving the body wrap flat on the table or workbench with the sticky adhesive side up, of course, unless you're trying to add a classy finish to your work surface instead of to your rocket. And that's really the only preparation needed. Now you can just gently roll it on, then press it to smooth out any air bubbles. And honestly, bubbles are fine. Don't worry about any bubbles that you may see. The body wrap is actually made from a material that allows bubbles to be pressed and the air will escape right through the wrap. They don't need to be popped with something sharp or pushed off to the side to release the air, which is really beneficial. On the other hand, any wrinkles in the wrap will be difficult, if not impossible, to remove later, so try to minimize creases or wrinkles if at all possible. Just press the wrap on the entire airframe all the way around and you're good to go. At this point, you can use a small hobby knife to remove any excess wrap from the edge of the airframe tube, just cutting it away and smoothing out the edge. There should only be a small amount of excess material to cut away here, depending on exactly where you applied the body wrap earlier. Once it's cut away, you can smooth the edge of the wrap just using your fingers. You can then use the knife or blade to cut away the wrap from each place where there's a vent hole or a hole for plastic rivets or for shear pins. For example, you should have 4 vent holes for the E-bay, another hole in the booster section, and 6 holes for plastic rivets to attach or remove the E-bay as well. Make sure to go back and count and make sure you didn't overlook any holes. It should be sufficient to cut the holes just using the blade, but if you'd like, you can always go back and drill through the hole again later after cutting it out with the blade if you want an even cleaner finish. Finally, you can use the blade to cut the wrap all the way around the airframe tube where the tubes separate. You'll do this 2 different times because they separate in 2 different places, between the booster section and the bottom of the E-bay, and then again between the top of the E-bay and the upper payload section. And again, once you cut the wrap away, you can easily smooth the edges out using just a finger. Here, of course, you can see the legendary Scott binder touching up the application of the body wrap. He's done this countless times, and he knows how to get that perfect finish. But next, you'll want to prepare the rocket for priming and painting the fins and the lower part of the booster section. To do this without messing up the beautiful wrap that you just applied, you'll want to cover the wrap in paper. Any kind of paper will do, whether it's just old newspapers or Christmas wrapping paper, tissue paper, whatever you have handy, and use masking tape at the bottom of the edge just to secure it. You just want to line up the masking tape with the bottom of the wrap all the way around, because anything that isn't taped off or completely covered in paper is going to be getting sprayed with primer and paint shortly. Similarly, to prep the nose cone for priming and painting, you can just use a hobby knife to cut away any excess plastic along the seam line and sand it down. Sand all the way around. Ready for prime time. Pun intended. Now you can take the booster section and spray it down with primer. You want to give it a very light coat, going all the way around on the airframe tube and both sides of each fin. Then you can sand away any buildup or imperfections and repeat. Another light coat of primer, and if you'd like, more sanding and more priming. You can repeat the process as many times as you'd like, depending on how smooth and flawless you'd like the end product to be. In my case, it was just prime, sand once, and prime again. Of course, it's always better to apply multiple light coats rather than a single heavy coat. But chances are, if you're building this rocket, you already have your L2 certification, and you've primed and painted many rockets before, so you've probably mastered this technique by now. And, of course, during this process, you'll want to wear some safety equipment, like an N95 or other respirator, as well as safety goggles or some sort of face shield to protect your eyes, as well as to avoid inhaling the particles from the spray. Using a similar technique, you'll want to tape off the shoulder of the nose cone and then spray the nose cone down with a light coat of primer. Sand off any buildup or imperfections and spray again, repeating the process until you achieve the desired result. You can sand with a power tool if you have one, or just manually with a piece of sandpaper. Either way, you'll probably need to use a flexible piece of sandpaper on the rounded sides of the airframe tube. If you do have access to a power tool for sanding, you can use it on the large flat surfaces of the fins to make the job a lot quicker. Again, you may want to wear an N95, a respirator, and face shield, but this is actually one of many nice things about working with cardboard and plywood rocket parts, as opposed to sanding down fiberglass and sending all that fiberglass dust into your face. Now you're ready to begin painting. Just as before, use a light coat of spray paint on the fins and the tube, sanding after each application of paint, and then doing another coat. You might want to wear old clothes that don't mind getting covered in a fine mist of spray paint for this too. While your paint on the fin can and nose cone is drying, you can attach the eBay to the payload section using the 6 plastic rivets. These just go into the same holes that you already drilled earlier. It's really easy to pop these in and out. To remove them, you can just use your fingernail and thumbnail, or you can use more advanced technology like the thin edge of a screwdriver or a similar tool. Next, you'll be cutting a hole in the tube for a camera, typically a GoPro. This is an optional step, and it's only necessary if you plan to fly your rocket with a camera on board, but by doing this, you'll create some unforgettable video. You'll want to measure first, so insert the Cam 5 altimeter bay into the eBay section of the tube, and use a ruler to see just how much it sticks out past the top edge. Once you do that, you can measure on the outside of the airframe tube just how far down to cut your hole, based on where the camera will actually be sitting in the Cam 5. Use a piece that comes with the Cam 5 altimeter bay to trace directly onto the airframe on the outside of the eBay section of the tube. There's either a square or a circle. Both are included in the kit, but you'll want to choose the one that's more appropriate based on your particular GoPro model or other camera. To cut the hole, you can simply use a hobby knife or blade, pushing it into and through the cardboard tube. Of course, be careful not to slip and cut yourself. Wearing gloves can help protect your hands for this step. Once the hole is actually cut, you can use sandpaper or a power tool like this Dremel sander to smooth out the edges. Simply test fit the Cam 5 altimeter bay, make sure that the camera port lines up just as you want it to. You can always clean up anything around the edges, just again using the blade or hobby knife and sandpaper or power tool. And for an even cleaner finish, you can use a black Sharpie or other marker just to darken all the internal edges as well.
Right now we're about to put together the motor mount tube adapter for the 75 to 54 millimeter motors. Just sanding the inside of some of these centering rings for the adapter tube. Just make sure that they fit over the edge here. There's 3 centering rings and the base plate. As always with a lot of these centering rings, you want to make sure that you sand enough so that it fits, but it should be snug. You don't want to overdo it and then have it too loose. You can always go back and sand just a little bit more. So right now I am just putting together the motor mount tube adapter, 75 millimeter to 54 millimeter adapter here, in case you want to use a 54 millimeter motor with this rocket. This is extremely easy to put together. Basically, it's just 3 centering rings and the base ring here at the end. And for each end of the tube, you just mark off a small line about 1/2 inch from the end. You slide this centering ring right up to that 1/2 inch mark, so you leave 1/2 inch here sticking out. And same thing on the other side, 1/2 inch jutting out here. The base ring and the centering ring just butt up right against each other, and then you've got one last ring right in the center, approximately, and that's it. You're just gonna epoxy all this together. I'm mixing up a small batch right now. One other nice thing about this is it's a fairly short adapter tube. You may end up using certain motors, especially with this rocket, the L3 Fusion, that are longer and go beyond the length of this tube, but you can always just take some masking tape and wrap it really tightly around the end. This is the base, obviously with the base ring here, but with this end, if you put the motor all the way in and the motor extends beyond, you can always just wrap some masking tape really tightly around this end, and that way with the ejection charge, it won't be able to go any further through the tube. You won't lose your motor, so you have some built-in retention that way. Pretty straightforward. The central ring, not super important. The exact location, just roughly halfway between the top and the bottom rings. But the top and bottom should each have about 1/2 inch of the tube sticking out on either end. You can also, if you want to, leave a little bit of space between these just to get some extra epoxy in between that final centering ring and the base ring. The nice thing about this adapter too is the base ring has these 2 holes in it, and you can screw it directly into the base of the rocket. That's perfect. And we will just let that cure. 12-minute epoxy cures pretty quickly, so don't have to wait too long before you can flip it over and do the same thing on the other side. Just cleaning up a little bit of this. It's totally fine to have some excess epoxy for each of these 3 centering rings, but for the base plate, or the base centering ring, you want to make sure that you clean up any excess epoxy, because that edge, you want it flush up against the base of the rocket when you use the adapter. So there can't really be any excess epoxy right there, just along that base ring. So at this point, this is the completed product. The rocket is looking amazing. We have the vinyl body wrap applied. Everything's cut at the seams where the rocket can come apart. The fin can primed, sanded, primed again, painted. Same thing with the nose cone. We have the holes cut out for the various vent holes, plastic rivet holes. There's a larger hole, as you can see here, cut out for the camera, where it'll be inside the Cam 5 altimeter bay, and we've cut it out using a sander and just kind of covered up using a black Sharpie just to kind of mask it a little bit more. But yeah, at this point the rocket is looking really good. Next step, we are just going to attach the 2 rail buttons. And to attach these, really straightforward, just going to screw them in, 1 screw per rail button, and we're just going to add a drop of CA, thick CA, otherwise known as super glue. Add a drop to each of the holes before screwing them in. This is one of the easier parts of putting the rocket together, although the whole thing is relatively straightforward, so simple enough. Number 2, the upper one. These are holes that were previously drilled in other steps. Drill it, apply some CA just to harden the edges, and then drill it again just to clean up the hole. So it's a nice clean hole, all ready to go for these to screw into very easily. And that's it. 2 15-15 rail buttons installed. So at this point, we are ready to do the recovery system. Shock cords, parachutes, quick links, it's all pretty straightforward. We have a couple of quick links here and 2 different shock cords, one about 15 feet and one 30 foot in length. And they don't have loops at the end right now, but it's extremely easy to put the loops in. I'll show you how to do this right now. Just find the end, any end will do, and just take it and loop it over once, double it up maybe about this much, 5, 6, 7 inches or so. It's about 6 inches here. And after you double it up, just take it and tie a single knot, single loop. And that's it. It's that easy. Also, if you have any frayed ends on your shock cord, you can always just take a lighter, like this Fusion lighter that we have here handy, and you can get rid of any kind of frayed pieces or ends, just like so. And that's it. So at this point we have knots tied in the end of both ends of the longer 30-foot shock cord, and just in one end of the shorter 15-foot shock cord. The other end, just leave it loose for now. It's the end that's going to slip through the nose cone area, and we will get to that in just a second. Just putting on quick link onto each of these ends. And then we're going to go ahead and attach them to the rocket. Of course, you have your steel U-bolts on the inside here. And this can easily attach using the quick link. Oh, sorry, the coffee.
Coffee's done, Dave.
No better way to start your morning than with a big cup of coffee and a large rocket. There we go. And I'm sure most, if not all of you, have done this before, but just attaching a quick link to the U-bolt in the rocket. One end of the shock cord is attached. So the length of this shock cord, this is a longer one for the drogue, and it is about 30 feet. So you want this roughly 3 or 4 feet from the top of the booster section, so maybe around here. You just take this, double it up, just as we did before with the ends of the rocket, and tie a single loop, and that is where the parachute will be attached. And this one is, of course, the drogue chute in the booster section. At this point, you can attach this a couple different ways. One is with a quick link. You can easily just take a quick link if you like to take your parachute on and off easily. Another way is to take the lines of the parachute, pass them through just like this, through the loop that you've just created, and then you can take the parachute itself and pass it right through the lines, and then you just pull it tight and it'll attach with no quick links at all. We are actually going to attach it using an additional quick link, just for ease of future removal or swapping out parachutes. But you can really do it either way, whatever you're comfortable with. You could use a swivel as well. One other thing you can do here is just take a small piece of masking tape. If you want to, you can mark off, just apply it right above where it attaches to the quick link, and that way you'll know where the center of the parachute lines are for the next time. Just a helpful tip. Just like that. And once the parachute is attached, all the quick links are attached, you can really just stuff everything inside. We'll do this a little bit more nicely in just a bit, but for now, everything's attached for the booster section and the drogue chute. And then we just do the same thing for the nose cone and the upper section. Here, you can see, of course, there's a steel U-bolt on the inside above the E-bay. And I'm just going to take this quick link, the end of this shorter shock cord, the 15-foot for the main chute, and attaching it to the U-bolt and screwing it into place. And the other end of the shorter shock cord attaches to the nose cone. Just on the bottom here. And this is just a simple, you can tie just a simple knot, double knot it. That. So similar to the longer shock cord, we're going to take a section roughly 3 or 4 feet from the nose cone, and again just double it up and tie another loop, just a single loop after you double it up, and that is where the other chute will attach. Again, you could really attach the chute here a number of different ways. We're just going to use a quick link to make it easy to attach or remove the chute going forward. And this is the main. And just as before, you can mark off where the center of the lines are, just above where the quick link is. For future reference, you'll know where the center is. And that's it. And just like so, we're good. All right, well, now we've finished putting together this motor. This is a reloadable M1297 motor, which is actually, as we mentioned before, the smallest motor that you can get level 3 certification with, surprisingly, given how large and heavy this thing is. Putting the motor together is just a pretty straightforward matter of following the instructions very closely, making sure all the O-rings go in the right place, making sure there's ample amount of grease or lube between everything, and this is a 4-grain motor. So for this step, we're just going to insert this into the rocket and secure it in place using these steel screws and retention clips. And this is also a good time to check and kind of test fit the motor in the motor mount tube. If it's a little bit on the looser side, and this is probably a little bit on the looser side, just to a tad. You can always just put a little bit of masking tape on it. Just wrap a layer or a couple of layers around the base of the motor itself, and then when you slide it in, it'll just be a little bit more snug right where you want it to be. And again, just using these screws and steel retention clips, one on each side of the motor, just to make sure that it stays in place and that motor is not going anywhere. One on that side and just one on the other side. And just tightening it up until it's fairly snug, just enough to make sure that the motor stays in place, it's not going anywhere, and that's it. Hi there. So just finished putting together the electronics bay here. We have the Cam 5 altimeter bay, which has been, actually it's probably easier to start with the unfinished one, just to show an example. This is what it would look like when the pieces are all put together and tacked together using some CA where they meet. But since doing this, I have coated the entire thing with West System epoxy, which is why it's a little bit darker than the other one, just to reinforce the wood everywhere, make it really tough and durable. Also added a couple of electronics here. You can see there's really a lot of room in this thing for pretty much everything that you can want in a rocket and more. I feel like there's no limit to this. Up here is a MissileWorks RC3 altimeter. There's room for two of them side by side. There's convenient slots, holes on either side to be able to access some of the switches, main, drogue, battery, the switch, and so on. This compartment here is where you can put a camera, GoPro if you have one, that you want to include in the flight. So in addition to camera and room for two altimeters up here, there's a lot of other space in this thing. It's really three-dimensional, and you can fit quite a bit in quite a few different areas. We've also included a flight sketch up here, which is really small and very easy. You could really put that thing just about anywhere. And as a backup flight computer, I've put in the telemetrum from Altus Metrum. So again, plenty of room for stuff. It's not completely wired up yet. We are still going to put together the ejection charges and wire everything together, drill another hole anyway in each bulkhead plate, the lower and the upper plate, just to run the wires through for the ejection charges. But otherwise, this is in pretty good shape. We've got space for a primary flight computer, a backup flight computer, a third redundant flight computer, just to make sure that we capture the altitude 3 different ways. And there's room for 2 separate batteries down here at the bottom, a 9-volt battery and a LiPo rechargeable battery, which is used by the telemetrum from Altus Metrum. So really a lot of different options here, and there's obviously plenty of space. You could easily mount something up here. There's another side. There's just so many nooks and crannies on this Cam 5. Really have limitless options. So you can get the L3 Fusion kit with 2 RRC3 altimeters, just 1 or none at all, depending on how many you already have, from previous kits or that you've purchased separately. Since the L3 certification process specifically requires that you have a primary and a backup flight computer for redundancy, there is the option to buy this with 2 if you want to use 2 and buy 2. But again, there's options to buy just 1 or none at all if you already have a couple of flight computers. So on to the next step. So having put together the electronics bay, we're just going to build a couple of ejection charges quickly. A lot of people do this in different ways. You can have end cap from PVC pipe as charge wells. In this case, we're going to build some omnidirectional ejection charges. You could do it however you'd like, whatever your preference is, but this is probably the simplest way, most straightforward, easiest way to put together some ejection charges. I will show you how to do it. Like I said, very, very straightforward. So we're going to use, for this rocket, 2 grams of black powder for the primary, and then 2.5 grams of powder for the backup charge. You start off just by taking any kind of plastic sandwich baggie. Something like this is perfect. You just cut the corner off, and I'll cut this one in a moment, but I've already got one here. All you want is just a little bit of a baggie, get the corner, and measure out your black powder. I'm going to put 2 grams in here. I have, along the same lines of simplicity, put together a very simple paper funnel, just so the black powder doesn't get all over the place. And this is just one of the 2 gram measuring kind of capsules that comes with a lot of motors. So just going to measure out 2 grams. So this is just the capsule to measure it out, but we're going to then transfer it into this little plastic sandwich baggie. So here's our black powder. So you could take your preferred type of electronic match and basically just insert the head of the match into the baggie with the black powder. And we are going to tape it and secure it. Make sure that the head of the E-match is right in there, wedged in with the black powder, and that the powder is all contained in one place. It's going to tape everything down. You can see, and actually you can move this red plastic part back just a little bit to get it out of the way for doing this step. Here I already ripped off just a few pieces of masking tape ahead of time because I don't have 3 hands. Here we go. So this first one, you just want to wrap it around very tightly, make sure that you totally seal it in so that the black powder isn't going to go anywhere. It's not going to fall out if you turn this thing upside down or something like that. So let's tightly seal it. And a couple more pieces of tape. Just want to get around the edges of this part of the baggie that has the black powder. It doesn't have to be extremely tight, just enough to kind of cover things up and protect it a little bit. So you have an additional layer over the sandwich bag, little plastic baggie. So here, just creating 2 more of these omnidirectional charges. Have the 2 primary ones done, and those are going to use 2 grams of black powder. These will be the backups, and so they'll use 2.5 grams. A little bit bigger, a little bit more powder than before. There's 2 grams, which is just the size of this little capsule. And let's measure out another 0.5. Yeah, there we go. And again, some of these steps, you know, we're assuming you're probably pretty familiar with a lot of the flight computers, electronics bay, how to build one, how to put together the ejection charges. Since if you are putting together the L3 Fusion and going for level 3 certification, you probably, presumably already have level 2 certification and have done a lot of this stuff before, so some of this stuff is nothing new and not necessarily specific to this rocket, but I thought it would be helpful to just demonstrate some of these techniques. And just as before, a few more pieces of tape. Doesn't have to be quite as tight, but just... And again, there's other ways to do this. This is just a very simple, straightforward, kind of quick and easy way to put together an ejection charge. It will detonate. It'll force the separation of the parts of your rocket airframe that you want, and it'll absolutely get the job done. So I've disconnected all of the shock cords and parachutes that we hooked up earlier with quick links and so on. Right now, we're just pretty much in the final steps of putting this rocket together. Just going to hook up the ejection charges that we put together a few minutes ago and wire them up to the flight computers. A little bit earlier in the instructions and the walkthrough, we drilled holes in the bulkhead plates, so we're able to pass through the ejection charge wires, 2 on each side, one for the main and one for a backup, through the lower and the upper bulkhead plates. And right now I'm just going to do that. I've kind of straightened these out, at least a decent amount, if not entirely getting rid of the spiral on the inside, but taking one of each of these, one that's 2 grams and one 2.5 grams, one for a main and one for a backup, just to kind of, as a helpful tip, I marked each end with some black Sharpie on this so that when they get pulled through the other side, you know which is which, because otherwise they look exactly the same. The one with the black Sharpie is the 2 grams of black powder for the main, and same thing on the other side. So it just may be a helpful practice to mark them or label them in some way so that when you pull them through the other side of the bulkhead plate, you don't get them mixed up. I'm just going to take both of the ejection charge wires for these electric matches, basically, and kind of twist the wires together just a little bit at the end and take the black plastic cap that they came with and get all of them inside there. This will just, it's not strictly necessary, but just to kind of help run these E-matches through the hole. It gives you something to work with. So all of them are kind of in the same single cap. Again, one of these is for the main and one is for the backup. So they're 2 slightly different size charges. And again, we've drilled a hole right through the bulkhead plate. You can probably see it a little bit more easily on this side because it's a lot closer on this side. And just running this through. Yep. You can see through the other side here. It's all 4, or the 2 sets of E-match cords are pushing through. And you want to give yourself plenty to work with on this side. I'll cut them shorter. I'll cut them to an appropriate length so that there's still plenty of room on the inside here with the electronics and the flight computers and so on to attach them. But there's no need to make them as short as possible, because I've definitely done that before, where you just you don't want to leave any excess cord and you cut them just a little bit short, and then you are suddenly finding yourself wishing that you had just a few more inches to play with. But so just pulling this all the way through, again having labeled with a black Sharpie one of the 2 cords, and I labeled it on both ends just to make sure I don't mix anything up in case I forgot. But the black one, the one that's labeled with the black Sharpie here, is the primary, or 2.0 grams of black powder. Once you've passed these through, you can take off the black plastic cap. That was just to kind of help pass it through the bulkhead plate. And these will attach to the flight computers. On this end, just pulling these almost all the way through. You may want to leave just I don't know, 2 or 3 inches or so. And the idea here is to tape them down, put a little piece of tape right over the hole to make sure that any of the ejection gases don't pass through and get into the flight computer area in the electronics bay. And then another piece of tape or two just to kind of secure them in place. Right somewhere near the U-bolt is good, somewhere around the center. You want to make sure that when they explode, they don't, they're not right up next to the side of the airframe. And you want to make sure that they are not too close to each other either, so that they don't activate each other. So spreading them out a little bit, kind of like in a V shape or V pattern from where they both emerge from the hole in the bulkhead plate is a good idea. So you want something like this where they're flat down against the bulkhead plate. I am going to tape them down, as I said, with just a little bit of masking tape, but that's basically the idea. And after that, just going to repeat with the other bulkhead plate, just again passing it right through the hole that we already drilled a little while ago. And you can always start off with a smaller hole. I think the instructions say maybe a 1/8 size hole or something, but you may find that based on the E-matches that you're using, and if you're using 1 versus 2, I mean in this case with the L3 Fusion you need to have 2 for redundancy, but depending on what you're using, and you can kind of do a test, you can always drill the hole bigger. You just want to make it as small as possible while you still can fit all of your wires through it. So these are both all the way through. Just going to grab some masking tape.
No masking tape for you.
But it's easily doable. Directly under the U-bolt, or right next to the U-bolt, somewhere, as I mentioned earlier, closer to the center and a little bit further away from the sides is ideal. It's looking good. Pretty secure. And just make sure that they're not right next to each other as well. And you can always put an extra piece of tape just over that hole where the wires come through, just to make sure that any hot ejection charge gases don't pass through down into where you have all your sensitive flight computer equipment, camera, all that expensive stuff. And I think this is good. And you can see where each of the black powder charges are for the ejection charges, somewhat closer to the center, but also a little bit spread apart from each other. And not too much extra wiring in there. Everything's taped down. Masking tape is really all you need to hold it in place. And again, just attach this other end to the flight computers and you're good to go. Just repeat on the other one. All right, I think this one is done. Now both of them have the ejection charges pulled all the way through. Again, just kind of spreading them out as well as possible here, keeping them somewhat away from the sides, but somewhat away from each other as well. Putting down a little bit of masking tape, just making sure everything stays in place, and a little bit more tape just to cover the hole so that any of those hot ejection charge gases don't come backwards through into your sensitive electronics. And on this side, just pull the wires through. Again, very helpful, not strictly necessary, but extremely helpful if you mark them ahead of time. Just making sure, a black Sharpie or some other color Sharpie if you want to, making sure that you can distinguish once you pull them through the hole which one is the primary and which one is the backup that has just a little bit more black powder. So with that, I think we're in pretty good shape. Just have to attach these wires to each of the flight computers and we'll be ready to fly this thing. So here I'm just attaching the ejection charge electric match wires to each of the applicable ports on the flight computers. We have the RRC3 and telemetrum from Altus Metrum. So right now, the batteries are safed. We have one that's actually attached to the battery. The other flight computer is not even yet attached, but neither one of them is connected. There's no switch involved here. As you can see here, these are the two ends of the wire that, when connected, will activate it in place of a switch, basically, just kind of simplify things. Right now they are separated and additionally covered with masking tape, just to make sure that even if they accidentally touch, it will not arm the rocket or arm the flight computer on the rocket. And just kind of measuring, cutting down some of these to a more appropriate size. You want to give yourself a little bit of room to work so that when you take it out, you're not just a few inches short and you have a little bit of room to play with. So earlier we marked the edges. It's the primary. It has 2 grams of black powder rather than 2.5. And I've been working on this one for just a minute now. Cutting the wire down to a more reasonable length, but still leaving enough to play with, and just stripping the ends off, just leaving a short amount of actual copper wire exposed. I'm sure most of you watching have already done this a number of times, and this is nothing new for you, but just hooking up ejection charges and make the primary flight computer here is the RRC3, and the slot for the drogue, or the 2 ports for the drogue, are up here. So this one has no black marker on it, and that means it is the backup. I'm going to leave it a little bit longer because I need a little bit more room to play with, because the port where it goes into the flight computer is all the way down here at the bottom on this telemetrum. So I'm just going to leave it a little bit longer and not cut the cord. I'm just going to trim the edges of the copper wire to a shorter length and split them apart just a little bit using a X-Acto knife. Let's see. Apogee slot for the drogue is right here. And I think this one is good. So now we have attached both the main and apogee to the primary flight computer and the main and apogee to the backup flight computer. This is the 84-inch main chute. Just completely unraveled it, took it out, made sure all the lines were not crisscrossed or anything, got everything straightened out. And just kind of as a helpful note, mark the exact center of each of the lines with the black Sharpie, just to help figure out where they should be and run them all at that point through the quick link. Also helpful to just put a piece of masking tape right here, just tightly winding it all together so that they don't move around too much, but tape is optional. It just kind of helps keep things more orderly. This quick link then we're just going to attach to the loop that we created a little while ago. Just double up roughly 3 feet or so from the nose cone in the upper section of the rocket, and that's where the parachute will attach. Just going to attach that now. And so we've used a quick link here and rolled it all the way back up again. Just gonna kind of take everything, take the shock cord and put that and the parachute into the rocket. And the final step here is applying, we have Nomex heat shields and Nomex shock cord protectors. And the heat shields have a little slit cut into one of the corners. And so the idea here is to take the end of the shock cord, and here you have the quick link at the end, the end that is closest to where the ejection charges will be next to the electronics bay, not the end closer to the nose cone. And simply pass this through. You can just drop, especially with the weight of the quick link, it'll drop right through very easily. Pass this end of the shock cord through the shock cord protector, and this just helps, again, protect it from fire. It's fire resistant. Not totally fireproof, but it will keep your shock cord in good working order for a lot longer than not using one at all. So again, just passing it through just up to this edge. You want to cover as much of the shock cord as you can with this, and then take the heat shield made out of the same material, Nomex, and pass this through as well. And just like that, I'm gonna take this, and some people like to just sort of stuff everything into the rocket. Some people like to take the parachute and shock cord and kind of wrap it up like a burrito. I know everybody has different preferred methods, and as with several other steps putting together this rocket for level 3 certification, you probably have already established your own preferences for how you want to put in the parachute, shock cord, and so on. So it's going to attach this end of this quick link and this end of the shock cord to, see the U-bolt, steel U-bolt down there in this upper end of the airframe. And that's really it. Just going to repeat the same process for the lower section underneath the eBay.
And I would take.
With this method, you can just put the heat shield up here and take the shock cord and the parachute and just put it right on top and put everything down into the rocket. Just took the shock cord, bundled it up, and going to insert it right on the top here for the heat shield, as well as the parachute, which, you know, again, everyone has their own method of how they want to insert the parachute. Some people wrap it up like a burrito. They like to fold it up in very specific ways, but this really should be sufficient. Pretty straightforward. It should protect everything with the rocket. And just pop that nose cone on, and that's it for the upper section. So we've already connected this end of it, and for the other end, just gonna do the same thing as before. Take the Nomex shock cord protector, drop the quick link, and this end of it, this is the end that's going to be closer to the ejection charge, and therefore the end that you want to protect from any kind of hot gases or blast. And then again, this is the Nomex heat shield, and you can just drop this through. There's a slit cut in one of the corners. You just drop it through, and it'll look like this. And this should be pulled down as much as possible to cover the full length of this end of the shock cord. And do you have any preference for how this goes in?
I just pack that shock cord protector, or that shield, right over that ejection charge.
Okay.
And then
So for this end, where we just attached the shock cord using the quick link, you really, I don't know if you can see it on camera, but you can really only have a few inches in here anyway. And you want to take this end of the shock cord and this heat shield, and you can stuff this end in here, and I'll do that in just a moment. That's, again, pretty much all you have room for because it only goes in a couple of inches. The rest of this 30-foot cord, as well as the parachute, can go into the booster section, and I'll put that in right now. And that way you have the important part where you have the heat shield over here protecting everything else against the ejection charges. And that's it. The nice thing about this rocket is it is really large. You have a lot of space inside to fit your parachute, shock cord, and yet it's really lightweight. I think we weighed it earlier. It's just about 11 pounds. And the motor actually is 11 pounds as well, the M1297. So total rocket weight with the motor fully loaded is 22 pounds. Extremely lightweight for a rocket of this size. That's really it as far as loading up the parachute and shock cord. Again, just stuffing the heat shield and shock cord protector end of things into this side. And then just piecing everything together. I think I'll be able to fit this in without adjusting the rest of the rocket. Perfect fit. And that's it. So last step, just going to drill a couple of holes for shear pins, and by shear pins I mean toothpicks. These are just round wooden toothpicks. All you do is drill a 1/16 inch hole and stick in one end of the toothpick, break it off. That will create a shear. Just got one hole drilled here and broke off edge of a toothpick, and that is your first shear pin. I'm just going to do one more on the opposite side. Probably right over here. Just enough to insert the end of the toothpick and break it off. You can actually, here we go. And that's it. That's a shear pin. And when you are getting ready to put this out on the pad, and you're talking to the RSO, just remind them that these are shear pins, so not to, remind them not to hold the rocket up vertically and bust open a shear pin, or it'll pull apart if they put too much force on it. So, but these are shear pins and toothpick is sufficient. So just going to do two more now on the nose cone. Same method as before. Here you probably want to go about an inch, maybe 2 inches or so below. You just want to make sure you're still within that shoulder of the nose cone, but a little bit further down from where the actual seam is. And you also want to make sure that it is firmly pressed against it. This one probably a little bit on the loose side, and can easily tighten that up with some masking tape around the nose cone shoulder or something. Not a big deal, but at least for this purpose, just firmly press them together and drill the 1/16 inch hole and insert the end of a toothpick, snap it off. Nothing a little masking tape can't fix, but just at least for purposes of putting in the shear. Just trying to get a little bit of a better fit. Right around here, it's about 1.5 inches or so from the edge of the nose cone. It's drilling another hole for a shear pin. And again, just a round wooden toothpick as a shear pin. You can get 2 shear pins out of this with 2 sides. Insert. And break it off. And there's your shear pin. Just going to put one more on. And final shear pin. And that's it. All done. All right, I think we're in good shape. This rocket is complete and basically ready to go. The motor is already built out. The M1297 reloadable motor is built and completely installed with the steel brackets keeping it in place, retention clips at the bottom of the rocket. Just kind of a quick checklist to make sure we've done everything. In addition to the motor, everything is hooked up. We've got 2 parachutes installed, the main and the drogue, each with its own shock cord, heat shield, shock cord protector. Everything is on, everything's in place. In addition, we have everything attached properly. We have the quick links, and each of the shock cords at both ends are attached. Everything is hooked up using quick links or just a really strong double knot. We have the electronics all installed. Everything's wired up in the eBay and ready to go. There's 2 different flight computers plus an additional flight computer, actually 3 in this rocket just for fun. But we have the primary and the backup flight computer ready to go, each with its own battery. Really, checklist is looking pretty good. Everything's in, even the shear pins are done. The only thing that we'll need to do in order to fly this thing once it's out on the field and get ready to put on the pad is put in a final couple of these plastic rivets. You can see there's one in here, but a couple empty holes. Just need to put those rivets back in, get it ready to go. And just need to put the camera into the appropriate space in the electronics bay and arm the camera, arm the electronics, and it's ready to launch. See you on the field.